Class example 1.5.2, write the following as entire radicals. In our last class example, we were looking at taking a radical and turning it into a simplified radical. But what we actually in fact did is we took an entire radical and created a mixed radical. A mixed meaning it has a coefficient as well as a radicand, which is the part underneath the radical sign. We're going to reverse that process. From class example 1.25.1, we could take a radical with a number in it, and we could break that apart into two factors of the same number, still being multiplied underneath that radical sign. Then we were able to break apart those radicals. Notice that I'm still multiplying and nothing is changing here. We've taken a big number, turning it down into its factors. Then we were simplifying it. And then what we did is we were looking for a perfect square, right? That perfect square turned into a nice coefficient. Oopsies. And then we were still multiplying it by a radical. So looks a little something like this. That perfect square would then be multiplied by whatever we had left going. So we're going to reverse that process. If I take 3 times the square root of 7, what I'm really looking for is I'm looking for a radical multiplied by another radical so that I can combine it all underneath 1. So I'm trying to take a radical and multiply it by another radical. Luckily for us, we've already got the square root of 7. But 3 had to be a perfect square to simplify down into that actual nice 3. So really what we're doing is we're thinking about, how did I get to 3? Well, I took the square root of 9. We know 9 is a perfect square from our perfect squares list. Then I can go ahead and I can multiply underneath one radical sign. Now see, we're getting into this entire radical, 9 multiplied by 7. And if I multiply 9 by 7, I'm going to get 63. And so I actually can say that the square root of 63 is the same thing as 3 times the square root of 7. One we call in a simplified mixed form, that's the 3 root 7. And one we call an entire radical, and that's the square root of 63. Okay, let's look at 3 multiplied by the 6th root of 7. We can still write this as an entire radical, but this time it's not the square root, it's the 6th root. So I'm looking for a 6th root all the way along here. And what we have, instead of a perfect square, we have a perfect to the power of 6. And then I'm going to multiply by that 6th root of something. So very similar to our 3 root 7. From 3 to the square root of something, well, I knew it was going to be 3 squared because I'm looking for this square root. We can do that with the same thing with this number 3, but this time, instead, we're not looking for a square root, we're taking a 6th root, so we're actually going to take 3 to the power of 6. Now don't forget, I could rewrite this with the 6th root, and it turns back, and the 6 and the 6th root actually cancel back out to be that 3 that we had in the first place. Now I still also have the 6th root of 7, which I had there in the first place. So you can see 2 separate sections here. Okay, 6th root of 7 and 6th root of 7 stayed the same. 3 is now turning to the 6th root of 3 to the power of 6, because I know those two will cancel each other out, just like the square root of 9 turned into 3. And now this time we can go ahead just as we did before, and I can take the 6th root of 3 to the power of 6 multiplied by 7. Now 3 to the power of 6, let's put that one into our calculator. I don't know that one off the top of my head, so I'm assuming maybe we're all going to need a calculator here. 3 to the power of 6 happens to equal to 729. I'm still multiplying it by my 7, and I'm still got my index of the 6th root. Now I'm going to take 729 and multiply it by 7, and I get the 6th root of 5,103. So 3 multiplied by the 6th root of 7 is the same thing as saying the 6th root of 5,103. Okay, let's look at 2 multiplied by the 5th root of 8. Now we know we want to have a fifth root multiplied by another fifth root so that we can get one big fifth root all together and then simplify it. So I already have the fifth root of 8 going on. I'm going to keep going with that 8. But what I need to do is I need to work on this 2 here. I know that if I wanted it to simplify like we did in our last class example down to a 2, I need a perfect fifth root. So in this particular case, I would take 2, multiply it by itself 5 times. So 2 times 2 times 2 times 2 times 2. Okay. When I do that, that's 2 to the power of 5. But if I'm taking the fifth root, it simplifies back down into that 2. So at least I know those will cancel out if I was trying to go the opposite direction. This time I need that 2 to the power of 5. 2 to the power of 5 happens to equal to 32. So when I combine these two together, I get the fifth root of 32, which is 2 to the power of 5, multiplied by 8. And when I multiply those two together, I get the fifth root of 256. So 2 multiplied by the fifth root of 8 is equaling to the fifth root of 256.